All right, for this video, we're doing practice problems for 5.4, which is factoring the difference of squares and perfect square trinomials. All right off the bat, we have factor the following. The first step for all factoring is always looking for a GCF. It looks like down this page, there aren't a lot of them that have GCFs, but we're always looking for the GCF first. And then when we have a binomial, we look to see if these are perfect squares, which means that they can be square rooted. Each term can be square rooted, which the answer is yes. If it's a difference or a subtract, then we have the difference of squares. To factor the difference of squares is just a matter of recognizing that you have squares that are subtracted. And then you square root the first term, goes here and here. X times x makes x squared. Square root the second term. 4 times 4 makes 16. And the signs are one of each, a plus and a minus. And that's all you have to do for factoring the difference of squares. The hard part is remembering and recognizing it. It's always a binomial, two terms, and each term is a perfect square. You can take the square root of it, and it's always a subtract. So is this a difference of squares? Yes, it is. They're perfect squares, and they're subtract. So the square root of the first term, square root of 25 is 5. The square root of x squared is x. And the signs are 1 plus 1 minus. Is this the difference of squares? Are they perfect squares? Yes, they are. Are they subtract? Yes, they are. So the square root of the first term, the square root of 9x squared is 3x. The square root of 49 is 7. And the signs are one of each, 1 plus 1 minus. Is this the difference of squares on number 4? Well, these are perfect squares. However, this is not a difference. It's a sum. And we can try to factor this by taking the square root of the first term and the square root of the second term. The square root of 4 is 2. But in order to get a plus here, this 2 times this 2 will have to be the same sign. They're either going to have to be both plus or both minus. And when you try that, by multiplying back, you're going to find that by giving them the same sign, the middle terms will not cancel off. And we end up with a 4x in the middle. So these are not good factors. By multiplying them back, you don't get the same expression. It turns out, you guys, that the sum of squares is prime. It does not factor. So if you end up with a binomial that are perfect squares, but it's a sum, it's addition, it's prime. It does not factor. Okay, this is not the difference of squares, and it is a sum like we just talked about. However, with this negative sign on here, we're not going to factor it anyway. We have to get the negative sign off before we can even talk about anything with factoring. So factor off a -1, and by doing that, we end up with x squared minus 100, which is the difference of squares. So always make sure you factor off this negative sign at the beginning first as the first step. Factor it off as a GCF, and then we're ending up with the difference of squares here. So the square root of x squared is x. The square root of 100 is 10. The signs are going to be 1 plus 1 minus. Don't forget, you still have to have this negative sign out here because it's a GCF. It doesn't go away. It's still there. All right, this is not the difference of squares. 2 and 8 are not perfect squares. However, we always look for GCF first. And the GCF here is 2. So we're going to factor off a 2. And we'll end up with x squared minus 4. And now we have the difference of squares in this binomial here. And so we can factor this down. The GCF is still going to be there. The GCF doesn't ever go away. It's still there. The square root of x squared is x times x. The square root of 4, 2 times 2. And we have 1 of each, plus 1 minus. All right, is this the difference of squares? It certainly is. The 4 and the 36 are both perfect squares. However, there is a GCF. They're both divisible by 4. So we need to take the GCF out first. And we're left with x squared minus 9, which is still the difference of squares because these are still perfect squares, and it is a difference. The GCF is still there. Now we can factor x squared is x times x. 9 is 3 times 3. We have a plus, we have a minus. So always make sure you get the GCF off first. Is this the difference of squares? It is. C squared and D squared are both perfect squares, and we have a difference here. So we can factor these. We can factor this as C times C, D times D, a plus, a minus. Number 9. Is this a difference of squares? Well, 121x squared is a perfect square. This is 11x times 11x. 84y4 is also a perfect square. We're going to talk about this in Chapter 6, but all of the even exponents, even numbered exponents, are all perfect squares. So the 4 is a perfect square, and 81 is a perfect square. So we can factor this. The square root of 121x squared is 11x. So we've got 11x times 11x. The square root of 81y to the 4th is 9y squared. The 9 times the 9 gives you the 81, and the y squared times the y squared gives you the y to the 4th, because we add the exponents when we multiply. And the signs will just be one of each, a plus and a minus. All right, on this page, we're going to do the perfect square trinomials. So these are no longer the difference of squares. These are perfect square trinomials, which factor differently than the difference of squares. So with perfect square trinomials, we're looking for perfect squares on the first term, perfect squares on the end term, and they always have to have a plus sign right here before the end term. So this is a perfect square trinomial. To factor perfect square trinomial, we take the square root of the first term, the square root of the end term, the square root of 81 is 9. And then we check the middle term by multiplying these together and doubling it, or times 2. So x times 9 is 9x, times 2 is 18x. If it does not match, then it's prime, and this is not going to work. If it does match, then you just pull down this middle sign. So we're going to pull down this plus sign, and we're going to put a square on, and we're done. So this is a shortcut, because you could still do this with your factoring methods for standard or square root trinomials. All right, let's try this one. Is this a perfect square? Yes, it is. Is this a perfect square? Yes, it is. Plus sign here. So the square root of the first term is x. The square root of the end term is 10. Multiply them together. 10 times x is 10x, and double it makes 20x. So you're good. Pull down the middle sign, put a square on, and you're done. Is this perfect square trinomial? Perfect square here, yes. Perfect square here, yes. Plus sign here. So take the square root of the first term, take the square root of the end term. Square root of 49 is 7. Check the middle. 2x times 7 is 14x. Doubled is 28. Pull down the middle sign, put a square on, and you're done. Perfect squares, plus sign, we're good. The square root of the first term is x. The square root of the last term is 5. Check the middle term. X times 5 is 5x. Doubled is 10x. Good. Pull down the middle sign, put a square on, you're done. Don't forget to put the square on, because without the square, it's wrong. Let's try this one. Do we have a perfect square here? Yes. And here? Yes. However, we don't have our plus sign here. So this is not going to work, guys. I think we talked about this in the lesson, that without the plus sign here, this turns out to be prime. You can try factoring it with different methods, but it's not going to factor. It's prime. All right, do we have perfect square here? Perfect square here, plus sign here. So let's try factoring it. The square root of 9x squared is 3x. The square root of 4 is 2. We need to check the middle. 3x times 2 is 6x. Doubled makes 12x. So pull down the middle sign, put a square on, and you're done. Let's try 16. Do we have perfect squares? Yes. Yes. Plus sign. Okay, let's try it. The square root of the first term would be 5x. The square root of the n term would be 6. Check the middle. 5x times 6 is 30x, doubled is 60x. So we're good. We can pull down this middle sign and give it a square, and we're done. This is a 6, by the way. Okay, do we have perfect squares here? Yes, yes, plus sign. Okay, let's try it. The square root of 49x squared is 7x. The square root of 16 is 4. I'm looking at the newest copy of the book. I must have gotten an old copy here because in your book this should be a 56, shouldn't it? My book has a 54, but yours has a 56, and that's going to make a difference here. So we took the square root of the first term. We took the square root of the n term. We're going to check now. 7x times 4 is 28x. 28x doubled times 2 makes 56x, and we're good. So bring down the middle sign and a square on it. All right, on 18 we have a perfect square here and here. 121 is a perfect square, and a plus sign here. So the square root of 9x squared is 3x. The square root of 121 is 11, and of course with the y squared there, the square root would be 11y. Check the middle. 3x times 11y would be 33xy. When we double 33xy, we get 66xy, so we're good. Pull down the middle sign, put a square on, and we're done.